The objective of this video is to give you an introduction about organometallic compounds and trying to understand the general reactivity of organometallic compounds. By now you're familiar with 4 different families of organic compounds, and you know that each family shows similar reactivity. For example, if you look into group 2, the organic compounds in group 2, what you see, you have this carbon chain connected to a group, either a halogen group like fluorine, chlorine, bromine, iodine, or oxygen, nitrogen, and sulfur. So in general, all these groups that is attached to carbon chain like halogens, oxygen, nitrogen, or sulfur, they are all nonmetals, and all of them are more electronegative than carbon. If you check the electronegativity of carbon and compare oxygen, nitrogen, all the halogens, and sulfur. So these nonmetals are mostly electronegative than carbon. So what does that mean? If you have this Z group, which is actually a nonmetal, this one is a nonmetal, and it is more electronegative than carbon. So what that means is this attached group is going to get a slightly negatively charged. If it is going to get a negative charge, what it means is that carbon is going to get a positive charge. So that means carbon can act as an electrophile. Electrophiles in general, they have electron deficiency. So that means if you have a carbon chain where a nonmetal and electronegative group is attached, carbon can act as an electrophile. So carbon can act as an electrophile. However, if this carbon chain is going to hold a metal, now this M stands for metals. Now check the metals. You know where you can find metals in the periodic table, and see what their electronegativities are. They are all less than carbon. Carbon is 2.5, and all the metals are going to have an electronegativity less than 2.5. So what does that mean? Metal is going to be less electronegative, so it is more like electropositive. So that means it is going to have a positive charge. From your Gen Chem, you already know that all the metals, they love to have a positive charge. So that means carbon is going to hold a negative charge. So when carbon holds a negative charge, we call them as carbanions. So what that means is that carbon is going to be more electron dense. That means it can function as a nucleophile. So that means depending on this group you are sticking to the carbon chain, carbon can act either as an electrophile or a nucleophile. In the event you are fixing a more electronegative group, it will act as an electrophile. If you are fixing a metal, meaning a less electronegative group, the carbon can act as an electrophile. Now, since we are talking about organometallic compounds, we are going to focus on organic compounds containing metals. Now, there are a lot of metals that we can use in organic chemistry as organometallic compounds. Most commonly used organometallic compounds are magnesium containing or lithium, copper, palladium. These are the most commonly used ones that you're going to find in many reactions. So the name says organometallic. So that means when we name these compounds, we put the organic part first and then mention the metallic part second. For example, magnesium containing organic compounds can be generalized as organomagnesium. Lithium containing ones, organolithium. For example, simple molecules that you already know. If you have lithium attached to butane, now we can call this as butyl lithium. You can see how this structure goes. You have ethyl magnesium bromide. We are not focusing that much on the nomenclature of organometallic compounds, but have an idea in general what the name says. So first you mention the organic part, and second you have the metallic part. By that way you can identify most of these organometallic compounds.